Hello everyone, good morning. So today we are getting into the most important part of this laws of motion chapter, which is the applications of the Newton's laws. So what we were doing so far is getting the basic understanding of what are these Newton's laws and what kind of forces we'll deal with commonly while we are doing the problems in the Newton's laws. So this is what we were covering, and also we talked about the law of conservation of momentum, which is derived from the laws of motion. So now the most important part of this chapter, which is where we'll get the questions from, will be the applications of the laws of motion. So applications of the laws of motion means we are going to apply all the three laws. So generally what people will think is that okay, there is only one equation we are going to use, F is equal to m into a, while doing problems in the laws of motion. But what we'll forget is we'll also use the third law, because when we are dealing with the forces, right, we are going to use the concept of the action reaction pair. We'll also use the first law, means when the object is at rest, we'll use the condition that the total force acting on the object is what? 0. So essentially the applications of the Newton's law basically will cover all the three laws as such. Okay, now when we look at the problems involving the applications of the Newton's laws, we will divide them into basically two types. One, problems where we have the balanced forces. So this is also what we call as the equilibrium. So here we are dealing with the translation motion of the object, right? That is what it is also called as translational equilibrium. That is why this is also called as what? Translational equilibrium. Okay. The other application will be when we have unbalanced forces. In that case, the objects are going to get accelerated. When there is unbalanced force, means the objects are going to get what? Accelerated. So we'll see the two categories separately. First is what? The case of balanced forces. Second will be the case of the unbalanced forces. Okay. So we will begin with the study of the balanced forces. So study of the balanced forces is also what we call as equilibrium of the concurrent forces. What do we call it as? We will call it as equilibrium of the concurrent forces. Why are we using the word concurrent? See, we are looking at forces acting on one object. We are looking at forces acting on one object. Let us say there are many forces acting on one object. If the total value of all the forces acting on that object is 0, that is what we call as the case of balanced forces or the equilibrium. So what is the equilibrium we are talking about here? Translational equilibrium. Because when we go to the rotation motion chapter, right, there we'll talk about one more equilibrium. We'll call it as rotational equilibrium. Okay. So when we look at the forces acting on the body, all of them will be acting on the same object, right? That is why we call them as what? Concurrent forces. Concurrent forces, when they add up to 0, that is what we'll refer to as the translational equilibrium or the balanced condition of the forces. Okay. Now this is the idea. How are we going to deal with the problems involving the balanced forces? So generally when we look at it, right, the problems involving the balanced forces, we will have two scenarios. Actually there can be a third scenario also, but we'll talk about mainly the two scenarios. The first scenario is when all the forces are in the same straight line. Means the forces acting on the body are confined to the same straight line. Means what? If you take the horizontal straight line, means some of them will be towards the right side, some of them will be towards the left side. If you take a vertical straight line, means some of them will be up and some of them will be down. You can also take some other inclined straight line. Some of these forces will be in one direction, some of them will be exactly anti-parallel. So then we will say what? All the forces are confined to one straight line. Then what will be the equation that we will get? Say here only we will call this as what? The total value of all the right side forces. When you add up all the left side forces, total value is what? 0. When you add up the right side force and left side force vectorial, the total value will be what? 0. But in terms of the magnitude, right, what will be the relation? The total right side forces magnitude will be equal to what? The total left side forces magnitude. Directions are what? Opposite. Magnitude wise, right, what will be the relation? Whatever the total left side forces, magnitude wise they will be equal total right side forces. Means, you know, I'm just telling you one very basic question. Let's say I'll tell that towards the right side there are two forces. One force is 5 newtons, other is x. Left side I'm saying there are two forces. One is 6 newtons, other is 1 newton. I'll say that, you know, there is an equilibrium. Then I can ask you to find the value of x. So what we are going to do? Total right side forces. What is the value or magnitude? 5 plus x. That should be equal to the total left side forces magnitude. What is it? 6 plus 1, which is what? 7. So which means what? X is equal to 7 minus 5, it will be equal to 2. Like that we will be able to use the equation. So the equation is what? It will relate the left side forces and the right side forces. Basically it will relate forces in one direction to the forces which are exactly in the opposite direction. Okay, so this is what is the condition of balanced forces when all the forces are in one straight line. So we are going to get how many equations? Just one equation is going to come. Okay, now the second is what? When these forces are not in one straight line but they are in a plane. When the forces are not in one straight line but they are in a plane, means what? All the forces will not be in the same straight line. Like the first diagram that I have drawn, right? What is it? Look at it. So if you look at the diagram that I have shown initially, like, you know, we have F1 like this, F2 like this, maybe F3 like this, maybe F4, like all these forces are in that 2D plane. All the forces are in the 2D plane. Now here, how are we going to bring the relation between these forces? Remember, any vector in the 2D plane, right, it can be resolved or taken. Any vector in 2D plane can be, what do we say, resolved into two independent components. What do you mean by the independent components? Which will be perpendicular to each other. That is the idea that we have taken in the study of the 2D motion, the projectile motion also, right? Whatever the horizontal direction, velocity, acceleration, those parameters will not be affected by the vertical. Means if you take the vectors into two perpendicular components, here what is the general directions we are going to choose? We will choose horizontal as one direction and vertical as the other. Means what? We are going to take all the forces components, each and every force will take the horizontal component. Sometimes what happens, here you see F2 is already in the horizontal, so there is no need to take components for that. F3 is already vertical, there is no need to take components. We have to take components for what? F1 and F4. F1 will have a horizontal component, vertical component. F4 also will have what? Horizontal component, vertical component. Okay, now along the horizontal direction as well as along the vertical direction, equilibrium means what? In any direction you see there should be equilibrium, right? Means horizontal direction also there will be equilibrium, vertical direction also there will be equilibrium. So here what we are going to get is, we will get two equations. What is it? When you add up all the forces, horizontal component, they will adding up to what? 0. Similarly, when you add up all the vertical components of forces, they also will add up to what? 0. So means in the horizontal, right, all the forces components to the right side, the value will be equal to forces components to the left side, they will balance. Similarly, all the forces upward components will balance all the forces downward components. Okay, so that is how we are going to look at the case where we have vectors in a 2D plane. This is also one common scenario. So here we are going to get how many equations? Two equations we are going to get. Okay, so each of the forces we will try to take the components. Generally what we will take horizontal and then vertical components. Okay, now sometimes what happens is we can have the components taken not in the horizontal vertical directions, but you will have case where you have to take components along two other perpendicular directions. That is generally done in the case of object on the inclined plane. So if you have an object on the inclined plane, right, let's say this is an inclined plane. This is what, this is an inclined plane. Okay, and we have an object on the inclined plane. So we have an object on the inclined plane. So we keep an object on the inclined plane. Then to study the motion of this object, right, instead of trying to study it horizontal vertical, what will be a better way to study is along the plane and perpendicular to the plane. If you remember, in case of that oblique projectile on the inclined plane, there also we said, right, we will study along the plane and perpendicular to the plane. So in case of object which is on that inclined plane, how do we take the forces components? We will not take them as horizontal vertical, but what we will do, we will try to take the directions as what? Along the plane is one direction, perpendicular to the plane is the other direction. Okay, so this is in which case? In case of any object on the inclined plane. Okay, so that will be a better way to study the object motion. Okay, so this is how we are going to deal with the equations when we have the concurrent forces which are in a plane. Now this is what we will generally have in most of the problems. First one also we will have in some problems, but most of the problems we will have what? The forces which are in a particular plane. Now there will be one more third category I said. That will be what? When the forces are in a 3D space. The forces, right? So 3D space we cannot represent in a plane diagram. But imagine, you know, like we somehow, like in chemistry and all, you will use these, you know, wedge notation like that. So think of it, you know, the forces are what? They are spread in a 3D space. Then each of these forces, right, we will take the x component. If they are balanced, means what? The total resultant value of all the x components will be what? 0. Similarly, the total y component value of all the forces will be what? 0. Similarly, the total z component of all the forces will be what? 0. So we are going to get, from here we will get how many equations? 3 equations we are going to get. We will get how many equations? 3 equations. Okay, so this is the way in which we will proceed with regard to the problems for the balanced condition of forces, or the case of equilibrium of the concurrent forces. What we'll do is because until we go to the examples, right, we will not be able to really get that idea how are we going to apply. So we'll jump into that examples. Look at the first question. A block of mass 8 kg is hanging from the ceiling to a rope. So we have a rope. The block, what is the mass of the block? 8 kg. Find the tension in the rope. We have to find what is the tension in the rope. So remember, when we talked about the rope assumptions, we said what? If the rope is assumed as massless, then tension everywhere will be same if the rope is on its own. Okay, but when the rope is rolling over a pulley, right, there are a different set of assumptions. Already we talked about it, but again when we go to the specific problem we will discuss. Here they didn't even mention about whether the rope is having mass or not. So when they don't mention, you know what, we have to assume that the rope is massless. That is a standard assumption. Okay, so here the rope is massless means everywhere in the rope the tension force will be what? Same, and that is what they are asking. That is what they are asking. Okay, so here we look at this block. The block is hanging, means, you know, it is just hanging, means this is at rest, or we can say this is having what? the equilibrium of forces. This is at rest, or this is having what? The equilibrium of the forces. Okay, means what? If you try to draw the, maybe the first problem you can listen to it, then the second problem I'll give you guys some time so that you can work it out. This 8 kg block, right? Can you tell me what will be the forces acting on it? It will experience its own weight. What is the weight? M into G, right? M is 8 kg and G is what? 10 meter per second square. They are saying normally we know G is what? 9.8 meter per second square. That is what we have to take. But if in a problem they are giving G is 10, means we have to take it as 10. So 8 into 10, what is it? 80 newtons. Okay. Now look at it. The block is hanging from the rope, right? Means it is connected to the rope. So there will be a tension. How the tension force will be? Tension force will be what? Into the rope. So from the block there will be a tension force acting into the rope. So tension is acting upwards. Tension force will always be what? The block is connected to the rope, means tension force will be always into the rope. Okay. So here you see there are two forces acting on the block. One is the tension upwards. Second is what? The weight of the block downwards. Because of these two, this is at rest or equilibrium, means what? Both the forces are in the same line, straight line. We'll get only one equation. Remember, what is it? In one direction, the total value of forces means what? Upward. What is it? T should be equal to the downward force. What is it? 80 newtons. So when the tension is 80 newtons, right? You see what is going to happen? Both the forces will simply balance each other. That is the condition for the block to be hanging from the ceiling. Okay. So this is how we'll be able to find the tension. So here we are able to find the tension by using that equation. The equation is coming from where? From that balancing of the forces. It is coming from the balance of the forces. Okay. So here we'll have only one equation. Why? Because all the only two forces are there. They are acting along the same straight line. Okay. So this is how we'll have to approach the problems to find out some missing quantities or variables. So this is how we'll have questions on the applications of the Newton's law with regard to this balancing of the forces condition. Okay. Now let us go to the next question. This one I will read the question, give you guys some time. You take your time, try to work it out. Put down your answer in the chat window so that I can see who is able to solve and who is not able to. Okay guys. So let us read the question. Now what is it? A block of mass 4 kg is kept on a horizontal table at rest. So we have to underline these important words. So there is a table. On the table the block is kept at rest. Rest means what? Equilibrium condition. Okay. So we have the block. What is the mass of the block? 4 kg. What is the normal reaction acting on the block? Here we have to find what is the normal reaction. Remember we discussed about the normal reaction. Either we use a symbol N or symbol NR or symbol R. All of them are used for indicating what? They are all used for indicating the normal reaction. So look at this guys. If you try to draw the free body diagram for that block, the block has got a mass. So it will have its weight. What will be the weight? Mass is 4. G is what? 10. So what will be the weight of the block? It will be 40 newtons. What will be the weight of the block? It will be 40 newtons. Then this block is resting on the table. The table is what? Horizontal. So you observe closely, there is a contact surface between the block and the table. This is the contact surface. This is the contact surface. And here you will have a doubt. Sir, no, whenever there is a contact between two surfaces, we said there will be two forces. One is of course the normal reaction, which will be normal to the contact surface. Second is what? Friction. Keep one thing in mind. If there is a friction, then they have to give us some information. Okay. What is the some information? We will be able to know. When we go to the problems involving friction, we will be able to know. Generally, we will be calling it as coefficient of friction. What do we call it as? Coefficient of friction. So they should give us the coefficient of friction. Only when they give that, right, we will be able to use the idea of the frictional force. If they are not giving, means what? This is a case of smooth surfaces. Either some problems they will particularly mention, assume that surfaces are smooth, or some problems they don't mention, then also we have to take it as what? Smooth. if you have to consider friction means they will either say the surfaces are rough. On top of it, they should also give us what? They should also give us the information about the frictional force, which is what we call as the coefficient of friction. We will learn about it once we go and study the frictional force. Okay. Now means between these contact surfaces, there is going to be only one force, that is the normal reaction. Friction we are not going to consider. Okay. So we are assuming that the surface are what? Smooth. Now from this contact surface, the normal reaction acting on that 4 kg block will be what? From the contact surface perpendicular into that object. So look at it, from the contact surface perpendicular into that object. Okay. So here also what do you see? Both the forces are acting along the same line, which is the vertical line. And equilibrium, they are saying rest. Means what? The upward force should be balanced by the downward force. Check it up, students. Who has got the answer for this? The answer for the normal reaction should be what? It should be 40 newtons. Okay. Okay guys, so this is how we have questions on balanced condition of forces when the forces are acting along the same straight line. Now we'll go to little bit, we don't want to call it as complication, but this is still a very basic question only. So this is where we have the forces acting in a plane. So look at this, a block of mass 4 kg is attached with two strings as shown in the figure in equilibrium. So this block is having how much mass? 4 kg. So this side we have a string, this side also we have another string. So on this block there will be two tension forces acting. How many tension forces are going to be acting? Two tension forces. Okay. So let us call them as what? T1 and T2. So this side tension is going to be acting into the string. Here also the tension is going to be acting into the string. Other than the tension forces, the block will have its own weight. What is the mass of the block? 4 kg, right? Weight means what? M into G. 4 into 10. What is it? 40 newtons. So how many forces? And by the way, the T2, right, will be along the rope. Means it will be making an angle theta with the horizontal. The T2 will be making an angle theta with the horizontal. What is the theta value, by the way? Pi by 6. Pi by 6 means what? 30 degrees. Now we have to find what? Tension in the strings. Means this side we have a different string, string 1. That side we have a different string. We have to find tension in string separate. Means we have to find what is the T1 value and also we have to find what is the T2 value. Try it out guys once. See here, right? The idea is like this. Already the weight is acting down. It's along the vertical line only. And this T1 is already in the horizontal. So we will take the T2 components. T2 we have to take what? Components. So look at this. T2 is along the rope, right? You take the components. Vertical component will be what? Up. Horizontal component will be towards the right side. So what is the horizontal component? T2 cos theta. The vertical component will be what? T2 sin theta, because it is making an angle theta with the horizontal, right? Horizontal component will be what? T2 cos theta. What will be the vertical component? T2 sin theta. Look at this. T2 cos theta will be like this and T2 sin theta. Okay. Now what is theta? Theta is 30. Means sin theta is what? Half. Cos theta is what? Root 3 by 2. So this is what? T2 into root 3 by 2. This is what? T2 into half. Now this is the case of forces in the 2D plane. Already we have taken components of the forces along the horizontal and vertical. We did not take the component of weight. Why? Because this is already vertical. We did not take the component of T1. Why? Because that is already horizontal. Only whichever forces are inclined, means neither horizontal nor vertical, right? Only those forces we will take components. Okay. Now look at this. Horizontal, the force total value should be what? 0, right? Because equilibrium means horizontal also it will be equilibrium, vertical also it will be equilibrium. Okay. Now I'm erasing this so that we can use the space to solve the question. Okay. So look at this, guys. What is going to happen along the horizontal means what? Left side there is T1, so the left side force should balance the right side force, means what? T2 into the root of 3 by 2. Let us call it as equation 1. Vertical, look at the vertical. What is it? Upwards is what? T2 into half is equal to downwards is what? 40 newtons. Take the T2 to the right side, it will go to the numerator. So T2 will be equal to what? 2 will go to the numerator, means 40 into 2 is what? 80 only, no? So what is it? 80 newtons. So we get it. What is it? T2 we got it. What is it? T2 is what? 80 newtons. So what is the T2 value? 80 newtons. Now we have to find the other tension also. T1 also we have to find, right? T1 will be how much? We'll go to the first equation. T1 is equal to what? T2, which is 80 newtons, into the root 3 by 2. So 2 40s. So how much it is? 40 root 3 newtons. That is T1. So T1 is what? 40 root 3 newtons. If you want to get the value in terms of decimal number, means we can take the root 3 value as what? 1.732 and then multiply it. Okay. So this is what will be the approach to solve the equilibrium in case where we have the forces in a 2D plane. Okay. Now we will go to, so I hope this is clear to you guys. So what did we do in this case? We looked at the forces. We have taken the components horizontal, vertical, horizontal direction, apply the equilibrium condition, means total force must be 0, means left side forces total is equal to right side forces, magnitude wise. Similarly, vertical direction, total force or net force should be 0, means whatever the upward forces, magnitude should be equal to the downward force magnitude. Okay. So we are able to get the values of T1 and T2. T1 is what? 40 root 3. T2 is what? 80 newtons. Okay guys. Now we will go to another question. Already we have seen one question. What is it? One block hanging from that ceiling with a rope. Here we have what? Two blocks are hanging from the ceiling with the help of two ropes. This is what? Rope 1 and this is the rope 2. Find the tension in each rope. The blocks are hanging, means what? The entire system is at rest. Block 1 is at rest. Block 2. Block 1, block 2 means we are talking about what? The 2 kg block and the 4 kg block. 2 kg block is at rest and the 4 kg block is also rest. Using that equilibrium of forces concept, we have to find what will be the tension in each rope. Means rope 1, let us call the tension as what? Maybe T1. Here also we will assume the rope to be what? Massless. That's why everywhere the tension will be what? Same. Rope 2, let us call the tension is what? T2. So we have to find what is the T1 value and what is the T2 value. Take a couple of minutes and try it out, guys. So we have to find what is the T1 value, what is the T2 value. So how are we going to approach? Again, we have to take each block, look at the forces acting on it. How do we do it? By drawing the respective free body diagrams. So let us look at just the 4 kg. It will have its weight. This is the 4 kg. It will have weight. What is the weight? They are saying take G is 10. Means weight will be what? 4 into 10. How much it is? 40 newtons. What is the weight of the block? It will be how much? 40 newtons. Okay. Then look at this carefully. The 4 kg block is connected to the rope 2. The rope 2 will be applying a tension force into the rope. Always any body connected to the rope, tension force acting on the body will be always into the rope. From that body it will be always what? Into the rope. Okay. Which means the tension force acting on the 4 kg block. In this case, the tension force is called as what? T2, because that is the tension we are taking. Tension in the rope 2 we are taking it as what? T2, right? So that is T2. So look at it, only two forces are acting on that 4 kg block, and luckily both of them are in the same line, which is the vertical line. Okay, now what is the situation? Equilibrium, right? Means the forces must balance. Upward force is what? T2, that should be equal to downward force 40 newtons. Straight away we get what is the tension in the rope 2. How much it is? 40 newtons. We get what is the tension in the rope 2. Now with this idea, you guys want to try how we can find the tension in the rope 1. Let us see if we can find what is the tension in the rope 1. For that, okay, we are done with the 4 kg block free body diagram. Now we have to go to the 2 kg block. We have to talk about the equilibrium of the 2 kg block. Let us see. Go to the equilibrium of the 2 kg block and try. For that, what we have to do? We have to draw the free body diagram. So I am erasing it. We are done with the 4 kg block study. That's over. From that, we are even able to get what is the T2 value. One of the ropes tension also we are able to find. Okay. Now where are we going to go? We will go to the 2 kg block free body diagram. Look at this. 2 kg block. It will have its weight. What is the weight? M into G, means M is 2 kg, G is what? 10. So how much it is going to be? 20 newtons. The weight value will be equal to what? 20 newtons. Okay. Now observe carefully one thing. The 2 kg block. Okay, so we are now just looking at the 2 kg block. The 2 kg block, right? Is connected to both the rope 1 as well as rope 2. 2 kg block is connected. You see, it is connected to rope 1. It is also connected to the rope 2. Means what? Look at what will be the tension because of the rope 1 from the 2 kg block. It will be into the rope 1 like this. Means tension acting on that 2 kg block will be what? Into the rope 1. What about the tension because of the rope 2 from the 2 kg block? It will be into the rope. Means T2 will be what? Into the rope, down. Now the object is in equilibrium. Means here also luckily we are having all the forces in the same line, which is the vertical line. Upward, what is the force? Only one force is there, T1. Balancing condition, right? Total upward force magnitude is equal to what? Total downward force magnitude. Downward means what? Downwards we have T2 as well as the weight. But already we got T2 value. What is T2? 40 newtons. So 40 plus 20 is what? 60. So T2 is 40 and T1 is what? 60 newtons. Check it, students. What must be the answer? T2 is 40, T1 must be what? 60 newtons. Okay, so we'll go to the next one. This is a kind of an important example. This is what we were referring to. The object on an inclined plane, or we also call it as what? Wedge. Object on the inclined plane or the wedge. Okay. Now look at the question. A block of mass 2 kg is held at rest on inclined plane by applying a force along the plane upwards. See here, this is what you are applying. The arrow, right? You are applying a force along the inclined plane. Along the inclined plane upwards. Okay, that force is basically for what? To hold the 2 kg block at rest. What is that force mainly for? The force is mainly for what? To hold the 2 kg block at rest. What is the value of this force? So they are asking us to find what is the value of the force. See, for a minute, right, just forget that there is this force. Generally, if you keep any object or anything on that inclined plane, Like, even if you go to the amusement park or recreation park, right, you'll see all these inclined things, right, on which people will keep coming down. What is the basis? When you're at the top of that inclined plane, there is basically a force that is trying to bring you down the plane. There is a force that is trying to bring you down the plane. What is that force? We will first try to understand. Okay, so if you don't apply, see here, how are you applying that force? You are applying the force along the plane upwards. If you don't apply the force, means then what is going to happen for the block? The block will keep moving down the plane, like the way you see in all these recreation parks, etc. People will come down the inclined plane, right? That is what is going to happen. Any object you keep on the inclined plane means assuming the surfaces are smooth. Assuming the surfaces are what? Smooth. So that is the reason why if you go to water parks, okay, especially in the water park and all that, you will see there will be this, huge tube that will start from somewhere at the top. Okay, people get into that tube, they will sit on that, small enclosure, and there will be, of course, the water falling, and the water basically will reduce that roughness, so it will create that smooth. So when you see the surface are smooth, means what? That object will be able to slide down easily. Okay, so that is what we will see in the recreational parks, etc. But let us come to our study in terms of the physics point of view. So what is it? If you keep an object on that inclined plane, what is going to happen? So let us just think about this 2 kg block here. So on the 2 kg block, right, for a minute, don't consider about this applied force. Don't think about the applied force. Okay, so for that, what I am going to do is I will draw the diagram here again. So this is the inclined plane, theta. So here, what is the angle? 60. So we are keeping an object here. Now this object, right, there is a contact surface, no? So it will experience a normal reaction, which will be normal to the contact plane. The object, whatever, here we are keeping the 2 kg block, means 2 kg block will experience a normal reaction. The 2 kg block will be experiencing a normal reaction. Now there will be also the weight of the 2 kg block, and remember, weight will be always what? Vertically downwards. On any object, weight will be always vertically downwards. And remember what we were saying, for the study of the block on the inclined plane, we will try to take the components of the forces along the plane and perpendicular to the plane. Here normal reaction is already perpendicular to plane, no need to bother about it. But look at the weight. Weight is vertically down. So we have to take the components of the weight. If you take the components, right, one weight component will be perpendicular to the plane downwards. You can see the arrow. It will be what? Perpendicular to the plane downwards. Maybe I will represent them with a different color so that we can see. One weight component is what? If you take the components, it will be what? Perpendicular to the plane down. Other weight component is like this. It will be what? Parallel to the plane downwards. So this is the reason. So weight has got a component which is parallel to the plane downwards. This is the reason, which is why the objects, when we keep them on a smooth inclined plane, what is going to happen to them? They are going to come down. Why they are coming down? Because there is a component of the weight which is acting along the plane downwards. Weight, when you take the two components, right, one component is perpendicular to the plane down. This one component is what? Perpendicular to the plane down. Other component is what? Parallel to the plane down. So this is the reason why the objects, when we keep them on a smooth inclined plane, they will start coming down. When we keep the objects on a smooth inclined plane, right, they will start coming down. Why? Because the weight has a component which is along the plane downwards. Weight has a component along the plane downwards. Now we will look at what is the actual value of these components. We said weight has components, right? We'll see what is the actual value of the component. Look at this. This is the block. So this is the direction in which we have our weight vertically down. So look at it. This is the perpendicular to the contact plane. This is the contact plane. This is what along the contact. So this is perpendicular. This is what along. Now you see there is a right angle triangle here. What is the triangle? This is a right angle triangle. So right angle triangle means if in one corner the angle is theta, means another corner what will be the angle? 90 minus theta. And look at it. This is along the plane. This is perpendicular. Means what is this overall angle? 90. So here we are just doing with the trigonometric relations. So the overall angle 90 means this part is what? 90 minus theta. So this part should be what? Theta. So theta plus 90 minus theta will be what? 90. So what are we able to conclude? The angle that the weight will make with the vertical to the plane. The angle the weight will make with vertical to the plane. Look at this. This is the weight. The angle that the weight will make vertical to the plane is what? Theta. So the vertical component is going to be what? Mg cos theta. Vertical component, it is making an angle theta, means what will be the component? It will be what? Mg cos theta. And what will be the component along the plane? It will be what? Mg sin theta. So the weight of that block which you are keeping on that inclined plane, it will have two components. One component along the plane downwards. What is it? Mg sin theta. Other component along, perpendicular to the plane downwards. What is it? Mg cos theta. So this is what we have to keep in mind. So whenever you have any other question where we have like this object on the inclined plane, we can straight away take what will be the component of the weight along the plane downwards? Mg sin theta. What is the component of the weight perpendicular to the plane downwards? It will be what? Mg cos theta. Okay, here what is theta? Theta is the angle of the inclined plane. Theta is what? Angle of the inclined plane. Okay, so now look at it. Other than the weight, there is a normal reaction acting. Already normal reaction is what? Perpendicular to the plane, up. Now look at it. Perpendicular to the plane, we will apply the equilibrium condition, because here what are the two directions we are choosing? Along the plane, perpendicular to the plane. Perpendicular to the plane means there is a normal reaction which is perpendicular to the plane, up, and there is a component of the weight which is perpendicular to the plane, down. What is it? Mg cos theta. So here normal reaction value will be equal to what? Mg cos theta. Normal reaction value will be equal to what? Mg cos theta. Okay, now what about along the plane? Along the plane we have a component of the weight which is Mg sin theta, down, along the plane downwards. And here what you are saying, there is a force that you are applying along the plane upwards. Let us call the force as what? F. This is what we are supposed to find. We are applying the force such that the 2 kg block will be held at rest. Means what? There should be no motion along the plane. Means the component of that weight downwards the plane, which is Mg sin theta, should be exactly balanced by the applied force. We are applying the force along the plane upwards. So this is what is our answer. So what is the answer? It will be what? Mg sin theta. But we didn't substitute the values. Why? Because this can be taken like a general problem also. Same problem can be taken like a general problem also. Okay, so what is it? M, we know what is M? 2. 2 into G is what? Everything is in the SI system. G is what? 10 into sin theta. What is sin theta means? Sin 60. What is sin 60? Root 3 by 2. So 2 ones are 2 tenths. How much it is? 10 root 3 newtons If you want to get the value in the decimal number means we can take root 3 as what? 1.732 and then substitute. Is it clear, guys? So if you have a block on the inclined plane, we take the weight components. Component of the weight along the plane downwards is what? mg sin theta. Component of the weight perpendicular to the plane downwards will be what? mg cos theta. Here theta is what? The angle of the inclined plane. Theta is what? The angle of the inclined plane. Okay. So this is how we are going to proceed when it comes to problems of object which is kept on the inclined plane. So here, instead of choosing horizontal vertical, what do we choose? We will choose along the plane and perpendicular to the plane as the directions. Okay, guys. Now while discussing about some common types of forces, right, we said that we will also talk about some more types of forces as we go into the further discussion. So one such force that we are discussing here is the force of buoyancy. What is the force here we are discussing? The force of buoyancy. Okay. So what is this buoyancy, which is also called as upward thrust? It is the force that will be exerted on any body which is either partially or fully immersed in a liquid. Not only liquid, it can be fluid also, because gases also can exert buoyancy force. But the buoyancy force because of gases will be considerably, negligible. That is the reason why we generally say what? Liquids. Okay. But the buoyancy as such can be applied by fluids. Fluid means what? Anything which can flow. When a pressure is applied, we call it as what? Fluid. Inclusive of both the liquids and the gases. Correct. Now look at this now. So this is diagram 1 and diagram 2. What is it? Here we have an object that is partially immersed. Here what do we have? The object which is fully immersed. What is it? Here the object is what? Partially immersed. Here the object is what? Fully immersed. Okay. Now let us see what is the buoyancy force acting on these objects. On any object which is either partially immersed or fully immersed in a liquid, right, the buoyancy or the upward thrust will be equal to weight of the liquid displaced. What is the buoyancy or upward thrust is equal to? It is equal to what? The weight of the liquid displaced. Okay. Now how we will calculate the weight of the liquid displaced? First we will see that. Then we will see why the buoyancy is equal to weight of the liquid displaced. So two things we have to do here. What are the two things? One, we have to check how do we calculate the weight of the liquid displaced. That is one. Because we are saying what the statement is what? Buoyancy is equal to what? Weight of the liquid that is displaced by the immersion. Okay. First we will see how we will get it. Then we will see why the weight of the liquid displaced is equal to the buoyancy force. Okay, both the things we will see. So how we will actually calculate the weight of the liquid displaced, and then we will see why the weight of the liquid displaced is equal to the buoyancy. So here first thing is what? To calculate the buoyancy by using the weight of the liquid displaced. That is a straightforward. So here the liquid displaced means, think about it. If you have a 2 liter volume object, or maybe 20 cc volume object, you think about fully immersing this into the liquid like this. What is the volume of this object? We are saying 20 cc. Okay, I just gave 2 liter because 2 liter is quite big. That's why, let's consider 20 cc. Okay, so we'll take a 20 cc object which we are putting fully into the liquid. Maybe we can even assume that liquid is what? Water for something. So if the 2 cc object is going in, means what? This much volume is previously occupied by water only, right, or the liquid only. Now that much volume is occupied by that object which we are keeping inside. Means the volume of the object that is immersed is equal to what? The volume of the liquid displaced. Whatever is the volume of the liquid is equal to what? Whatever is the volume of the object, that much amount of the liquid is displaced. Okay. Now here in this case, what is going to happen? It's a partial immersion. Here, full body of that object is not immersed. Only some part of it is immersed. Here also same thing. The volume of the object immersed. Okay. The volume of the object that is going in will be the volume of the liquid that is displaced. Okay. Now weight of the liquid that is displaced. First let us calculate what is the mass of the liquid displaced. What will be the mass of the liquid displaced? The displaced volume into rho. Here rho is what? We'll say rho is the density of the liquid. Okay, so volume into density, what is it? The mass of the liquid that is displaced. Weight means what? That is what we are saying is buoyancy, right? Weight means what? Mass into G. That's it. So this is the buoyancy. So always, what is the buoyancy force value? Weight of the liquid that is displaced means whatever is the volume of the object that is immersed inside, that is what will be the volume of the liquid displaced. So Vd into rho. Rho is what? Density of the liquid. Rho is not the density of that solid. Rho is what? Density of the liquid. Okay. Into G, because buoyancy is what? Weight of the liquid displaced. What is the buoyancy? Buoyancy is what? Weight of the liquid displaced. Okay. So this is how we are going to calculate the buoyancy force value. So always buoyancy is what? Weight of the liquid displaced, which is Vd, volume of the liquid displaced, into rho. Rho is what? Density of the liquid into G. So this formula we have to remember. Okay. Maybe I'll just write on top of it. What is the formula we have? What is the formula for the buoyancy force? Vd into rho into G. Okay. So here Vd is what? The displaced liquid volume. Okay. And rho is what? Density of liquid. G already we know. Okay. So this part is over. Now we have to understand why the buoyancy force. We are saying straight away buoyancy is equal to weight of the liquid displaced, right? We should understand why are we saying that buoyancy is equal to weight of the liquid displaced. For that, right, take case 1. We can do the derivation by using either case 1 or case 2, whichever case. Let's take case 1. The volume which is now occupied by that solid object is previously occupied by what? The liquid itself. No. Previously, if you take the vessel with just the liquid, whatever the volume that is occupied by that object now, the immersed volume, that is previously occupied by what? The liquid itself. No. Now what I am saying is, take the liquid. So this is what is that? Displaced liquid. Okay. So this is what is the displaced liquid. Take the displaced liquid free body diagram. Take the displaced liquid free body diagram. Okay. Now on this displaced liquid, we know that there will be that weight acting on it, its own weight. This is what we are calling as the weight of the liquid displaced. The liquid displaced, we are taking free body diagram. Now there is a downward force which is the weight, but this liquid is at rest. Means what? There must be some force acting which is able to balance the weight. How does this force come? It will come from the interaction with the nearby liquid molecules. The nearby liquid molecules will interact. Whatever the volume of the liquid displaced we take, right, the nearby water molecules will interact with it. Nearby liquid molecules will interact. Okay. We don't need to worry about what is the kind of interaction and all that. Maybe in the properties of fluid chapter, we'll talk about what can be the types of interactions between the liquid particles and liquid particles. But here we don't need to worry about them. So idea is there is some kind of interaction between the surrounding liquid particles and this volume that we are considering. This is what the volume of that liquid which is displaced whenever we are immersing. Okay, now the resultant of all the interaction forces, the resultant of all the interaction forces, right, should be what? Upwards, which is able to balance the weight. Then only that liquid is going to be at rest. Then only the liquid is going to be at rest. Okay, which means what? The resultant of all these interaction forces will be simply equal to what? It will be equal to weight of the liquid that is displaced. And the resultant of all the interaction forces will be what? Upwards. It will be what? Upwards. Now just to go back, here this much amount of volume is now occupied by what? It is occupied by the solid object, but the surrounding liquid molecules, right, they will still apply the same interaction force, almost same interaction force. The surrounding, they will apply almost same interaction force, which means what? Their resultant, all the interaction, so the surrounding molecules, they will apply the same interaction force. The resultant of them will be equal to what? R, which is same as the previous case. What is the R value going to be? R will be equal to what? The weight of the liquid displaced. R will be equal to what? The weight of the liquid displaced. So when we are immersing a solid object, means the surrounding liquid molecules will still keep applying that same interaction force. The resultant of all the interaction forces will be what? It will be upwards. And it will be upwards, how much value? It will be equal to the weight of whatever the liquid that is displaced. It will be equal to the weight of the liquid that is being displaced. Okay, so this is what is the buoyancy, and buoyancy will be what? Always equal to what? Weight of the liquid displaced. Okay, so this is how we will be able to calculate the buoyancy. And again, here we are able to get how the buoyancy is equal to weight of the liquid displaced by using the Newton's laws concept. We will talk about the buoyancy again one more time when we go to the properties of fluids. Okay, there in properties of fluids, right, we also talk about this particular condition. This is called as condition for floating. Floating means what? Only some amount of the object must be immersed. So floating, we can also say it as what? Partial immersion. Okay, so this we will see again in the properties of fluid chapter also, but this is a very straightforward result. Condition for floating. So we will see what is the condition for any object to float. Any object to float on the water surface. So take the object. Okay, so let us consider the object is a solid generally. So rho s is what? The density of the solid object. Okay, rho is what? Density of the liquid. Okay, now if we assume that it is partial immersion, let us say Vd is what? The volume of the object that is immersed, and V is the total volume of the object. So volume of the object immersed means what? That is the volume of the liquid displaced also. Okay, now we have taken rho s is what? The density of the solid. Rho is the density of the liquid. Vd is what? The volume of the object that is immersed. That is the volume of the liquid displaced. V is the total volume of the object. Now let us draw the free body diagram of the object. The object will have its own weight. What will be the weight? Mass of the object into g. What is the mass of the object? Density of the object or the solid object, which is what? Rho s, into what is the total volume of the object? V, into g, that is the weight. There will be buoyancy force. Generally we will represent the buoyancy with what? B. What is the buoyancy force? It is the weight of the liquid displaced. Already we have seen the formula, right? What is it? Rho, which is the density of the liquid into volume of the liquid displaced into G. Floating means what? Floating means both these forces should balance. Buoyancy force should balance the weight, right? So what is the condition for floating? Means the forces must balance. So when they balance, what we are going to get? So look at it. I'm assuming you would have copied all these notations. So this is important. So we are going to get a relation or a formula, but we should know what each of these terms represent. Then only it will make sense. Okay. So that is why we are spending time on writing each of these quantities, what they actually represent. So what is the condition for floating? So condition for floating is nothing but what? Balancing of forces. That's it. There is buoyancy up, weight down. Balancing should happen. Means what? Buoyancy value, which is what? Rho, which is the density of the liquid into volume of the liquid displaced into G. Buoyancy should be equal to weight of the body. G is cancelled. So rho into Vd is equal to what? Rho S into V. Okay. Now look at this one. Floating means what? Only some part of the object will be immersed. Means what? Vd will be less than V. We can say extreme case means what? Less than or equal. Then it will be what? Less than. Okay. So Vd will be what? Less than V. Floating means only a part of this will go inside. Other part of that object will be outside only. So Vd will be what? Vd is the volume that is immersed. The volume immersed will be less than the total volume, right? That is what is the situation of floating. Now remember this. Here you are saying like what? It's like what? A into B is equal to X into Y, like that. A into B is equal to X into Y. Now if B is less than Y means what? Vd is less than V means A must be more than X. A must be more than X. Then only A into B will be equal to X into Y. Correct or not? So here Vd is less than V means what? The rho value, right, should be more than rho S. So this is what we call as the condition for floating. What is it, guys? Rho means what? The density of the liquid should be more than density of the solid. So why ice will be floating on water? Because the liquid density, water density is more than the density of the ice. So when you take some wooden pieces and throw them on water, the wooden pieces, they will float on water when the water density is more than the wooden piece. So floating will come when the density of the liquid is more than density of the solid. That is the reason why generally if we just jump into water, right, what will happen? We will be sinking in. We will not float. But if you go to some places like in places like Red Sea and all that, where at certain locations, not everywhere, at certain locations inside the water, the concentration of these ions and mineral particles will be so high that it will give a very high density for water. So even we can also be floating on the water just like that, because the density of the water at those locations will be significantly high because of the concentration of these ions and mineral particles. Okay, so guys, what is the condition for floating? The density of that liquid should be more than density of the solid. Now you know why ice will be floating on water. Probably in chemistry, if you have studied the hydrogenated compound, right, you will study that the ice will have lesser density than water. That is the reason why ice will be able to float on the surface of the water. Okay, so this condition remember, because we are again going to talk about it when we go to the properties of fluid chapter. Okay guys, so we have begun with the condition of the balancing of forces. So what we have covered in today's session mostly is what? The balancing of forces, applications of the Newton's laws. Then in the next session we are going to start with the idea of unbalanced forces. So when the forces are not balanced, then obviously the object is going to get what? Acceleration. So next class we will start with the idea of motion of the object when there are unbalanced forces acting on the object. Okay, we will see in the next class.